Section 7.2 today, ratios and similar polygons. So continuing on here in chapter 7, talking about ratios and proportions. Now we're going to apply this to what it is in similar polygons. All right. So first thing we need to talk about is, what does it mean to be similar? A similar polygon are polygons that have the same shape but not necessarily the same size. All right. A lot of times when I talk about similar, you talk about like model cars, model trains, model planes. Has anybody ever seen like one of those model boats? Those different things? Alright, so again, similar polygons are polygons that have the same shape but not necessarily the same size. As I was saying, a lot of times you think of like model cars. Okay, sometimes people make model cars. They're a replica of the exact car, just to a smaller scale. Okay, these shapes, these two triangles are similar. The similar objects use a similar symbol. It's a squiggle. Okay. How do I know angles are the same? They are marked with a congruency symbol. Okay. In order to be similar, they have to have the equal angle measures, and then their side lengths have to be proportional. So for instance here, what is the relationship between those two sides? They're half or they're times 2, depending on which way you look at it. Same thing here. 10 and 5, half or times 2. And then I have 9 and 4.5, half or times 2. All right? As it states down here, a similarity ratio is the ratio of the lengths of the corresponding sides. So for the similarity statement, a triangle ABC is similar to triangle DEF. The similarity ratio is 2. But for triangle DEF is similar to triangle ABC, the similarity ratio is 1/2. So depending on which way you look at it, they could have different similarity ratios. Okay, so make sure you're looking at it one way or the other. And again, they show that right there. We want to identify the pairs of congruent angles and corresponding sides. So for instance here, let's talk about angle J. What would angle J be congruent to in this problem? M. How do we know it's congruent to M? They have the congruency symbol. So I would say angle J is congruent to angle M. Nice job. Well, what's another one after J and M? What would be another one?
L and P.
Angle L is congruent to angle P. How do we know that? The two congruency marks there. Nice job. Now, K doesn't have a congruency mark. K doesn't have a congruency mark. So what would angle K be congruent to, though? Why angle N? Yeah, they both don't have congruency marks. So if two angles are the same, that means the third angles are also going to be the same. Okay, we talked about that back in chapter 4. Now let's talk about sides. What about JL? What would JL be similar to?
NP.
JL would be similar to what?
PM.
Why MP? Because you have 1 mark to 2 marks, right? So JL is similar to MP. Nice job. What about, let's go KL. What would KL be similar to? NP. Or PN. Okay, I like doing the same letters in order. So KL is similar to NP. And last one, what about KJ? What would KJ be similar to? NM. Nice job. Shh, quiet. NM. Again, use the congruency symbols to mark the congruencies, then use them to help you find the side lengths that are similar. All right? Take a couple seconds, try number 2 on your own now. Match up the congruency or the congruent angles and the corresponding sides. All right, let's walk through number 2 here. If I were to look at angle A, Becca, what would angle A be congruent to? Angle Q. Nice job. Audrey, angle B. What would angle B be congruent to? Angle R. Luis, angle C. What would angle C be congruent to? Angle what? Angle S. And angle D. What about angle D, Jeremiah? Angle T. Now let's talk about AB. What would AB be similar to, Trent? Similar to QR. And then I could do BC. What's BC going to be similar to, Quinn?
BC.
Yeah, what's BC similar to?
RS.
RS. Let's talk about CD. What is CD going to be similar to, Tyler?
ST.
ST. And last but not least, I have DA. What's DA going to be similar to, Jake?
No.
TQ.
Bad.
Nice job.
Bad.
No.
Shh, quiet.
Beast is not bad. Bad is
Okay,
beast.
next one here. We want to determine whether the polygons are similar. If so, we're at the similarity ratio and a similarity statement. Okay, to identify whether they're similar, the angles have to be congruent and the sides have to be proportional. Okay, like they have to be the same ratio, like double, like all the sides have to be double, or all the sides have to be like triple or something like that. Okay, so as I look at this here, shh, focus. As I look at this, what's angle F going to be the same as?
J.
What's angle G going to be the same as?
K.
Okay, so if two angles are the same, what about the third angles? They're also the...
Same.
Okay, so I know the angles are all congruent. Great. Now let's look at the sides.
Nope.
What about 10?
Nope.
What's 10 going to be similar to? 15. Okay, so let's look at 10 over 15. What's 10 over 15 simplified to? Isn't that just 2/3?
Yeah.
Okay, so let's look at the next one here. Pay attention. What about 12? What's 12 going to be similar to? Okay, so I have 12 over 18. What's 12 over 18 simplified to? Huh. Interesting. Anybody want to take a guess what the last one similar to?
That is not.
What's 17 over 25 going to equal? What's that equal?
I'm just gonna guess 2/3.
2/3.
Oh my goodness.
So are they similar?
What?
Yes, they are. Quiet. They are similar. Okay, and what's the similarity ratio then?
2/3.
Yeah, the ratio here would be 2/3. Nice job. Okay, 4. Now let's look at 4 here. Well, first off, it's a rectangle. So what are all the angles in a rectangle?
90.
90. So I know all the rectangles are the same. Nothing to worry about there. Now let's look at the sides. 15. What would 15 be similar to? 5.
It's triple.
So 15 over 5 equals what? 3 over 1. Well, let's do the next one. 24 and 8. 24 over 8 gets me 3 over 1. Is that yes or no?
Yes.
Yes. So is it similar?
Yes.
What's the ratio? Nice job. Okay, so again, don't just say no because it's a decimal. Actually, you have to work it out. Next thing we're going to do is actually going to work using the ratios to solve some proportions. You can use proportions of similar polygons to solve problems. For example, rectangle DEFG is similar to rectangle JKLL, or HJKL. What is the length of HJKL? Well, most people make mistakes here. Okay, the biggest mistake I see students make is they want to go like this. They want to say 40 over 18 equals 27 over x. Okay, what do you notice they did? They said, oh, these two are on top, these two are on the sides. Well, I'm just going to line them up top and bottom.
No.
What's wrong with that though?
Because 18 is the short side.
Yeah, look at this. 18 is the short side. Which one's the short side over here?
27.
27. So that doesn't work. You need to line it up like this. 40 over x, again, long side with long side, equals 27 over 18, short side over short side.
Wow.
Okay, and then you use cross products to solve. The biggest thing, you can set these up a couple different ways. The best thing you have to do is you have to be consistent how you set it up. So if you do length over length and width over width, make sure you do the big one over the small one and the big one over the small one. Or small over big, vice versa. Okay, so let's look at number 5 here. You can use a calculator on these problems. Some of these have some decimals, so work on them. 5. A rectangle is 3.2 centimeters wide and 8 centimeters long. A similar rectangle is 5 centimeters long. What's the width of the second rectangle? I need to set a proportion up here. Colin, how would you set up a proportion on number 5? So you did 3.2 over x equals 8 over 5. So notice he had his widths over here, and then his lengths over here. Okay, he had the two triangle or the two rectangles. These were together, and these were together. So they're all paired up. And then I can use cross products. Again, could I set it up a different way? You bet. I could have flipped those around at x over 3.2 and 5 over 8. I could have done 8 over 3.2 and 5 over x. Okay? You just have to be consistent. When you work it out and you do cross products, what do you get for an answer to x?
2.
2 centimeters. Nice job.
That's all you have to do?
Yep.
You don't have to well get back in.
No, that is it.
Yeah, I know. Yeah.
And then take 16 divided by 8. Now 6, pay attention to 6 here because you have to do some reading here to understand. Rectangle CDEF is similar to rectangle GHJK. And the similarity ratio of CDEF to GHJK is 1 to 16. So that means for every 1 inch CDEF is, what do you know about GHJK? It's going to be 16. Okay? I need to set a proportion up. What do you notice? They give me one of the proportions already. They give me a ratio already. What's the first ratio they give me? 1/16. Okay, so I have 1/16 equals. I have another number here. It's D equals 20. Now D equals 20. Will that be in the numerator or denominator? I heard both answers here.
It could be either one.
Could it though?
Yeah.
No.
What's DE representing here?
It's representing
The first rectangle, right?
Yeah.
Okay, so which one of these is representing the first rectangle? 1 or 16? 1 goes there, 16 goes there, because it goes in order, right?
Yeah.
So again, should DE be in the numerator or denominator? Numerator. So I'm going to say 20 over x. Recognize, they're giving it to you in a particular order. You need to read it and set it up in the same order. So 1/16 equals 20 over x. When I work that out, Blake, what do you get? X equals 320. Nice job.
Whoa.
That is
Don't use the JC in here.
Thanks, Anderson.
You're welcome.
All right, take a couple seconds, try these two on your own. All right, now before you get going on number 7, you might have to think about on FE, quiet. You might have to rotate it. Okay, you might think about picturing this rotated a couple degrees. Okay, shh. And 8, make sure you rotate it as well. So take a couple seconds, try these two on your own. Jake, coming to you on number 7 here. Okay, Jake, let's walk through this here. Jake, how'd you set up a proportion? So you did 15 over x. You're saying 15 and x are similar, and I'd agree with that. Okay, so what would that be equal to then, Jake? 12 over 19.2. I would agree with that as well. 12 is similar to 19.2.
Wait, can you put...
And again, if I look at it here, could I use the triangles? Well, AB is similar to DE. Oh, hey, well, you know, AB is similar to DE. We got that. BC is similar to EF. Hey, look. That's marked for us as well. Okay. And when you do that, what do you get for an answer then, Jake? X equals 24. Nice job. Now, question read.
How come you have to put 19.2 on the bottom?
Could I have done x over 15 and 19.2 over 12? Yeah. I could do this like 3 different ways. The biggest thing is you have to be consistent how you set it up. Okay? 8. Trick question here on 8. Let's see who got it. Reed, set it up for me.
I put 18.6 over 12.5
Ah, you set it up correctly already, yes?
and 12 over x.
Nice job. Recognize, the biggest mistake students make on a problem like this, they go, hey, these two numbers on the sides, those two have to be together, and these two, well, top and bottom, those two have to be together. But what's wrong with that? Yeah, this rectangle, you have to actually think about like rotated down. If you were to flip it down, now it's similar and it's kind of shaped there in that
I
way.
think I have the right answer.
Now you use cross products. It says round to the nearest tenth.
Yeah, so it'll be 8.1.
It would be 8.1. Nice job. So I think you got like 8.06 something.
8.06 something.
Yep. So you get 8.1. Nice job. All right. These two. Take a couple seconds here. Listen up. Number 9. It says triangle MNP is similar to triangle QRS. And the ratio of MNP to QRS is 5 to 2.
5 over 2.
MN equals 42 meters. I need to set up a proportion. Again, they give this to me in an order. It says MNP to QRS is 5 to 2. What's the 5 go with? MNP. What's 2 go with? So have 5 over 2 equals. Now let's look. MN. What's that going to go with?
First one's on top.
So that would be on top. So 42 over x. Take a couple seconds to finish that one on your own. All right, yeah, so when you work this one out, 5 times x, 42 times 2, you end up with 84 equals 5x, or x equals 16.8. What was my unit now? Meters. Okay, now next problem, number 10. Pay attention here. Triangle HJK has side lengths 21, 17, and 25. Can we put those in orders from least to greatest? What would that be in order from least to greatest? Okay, so least to greatest, 17, 21, 25. Awesome. It tells me the two shortest sides of triangle WXY are 48.3 and 39.1. Those are the two shortest sides. Let's put those in order.
39.1, 48.3, x.
And I need to know the longest side, right?
Yeah.
So can I just call the third side x
Yeah.
right now? Awesome. I want to find the length of the third side. Could I set a proportion up to solve this? Yeah, how could I set a proportion up to solve this? What are you thinking there? Oh, Tyler Wilson, what are you thinking?
39.1 over 17 and x over 25.
Yeah. Look at this. I already have them listed. Short sides, long sides. They have to be similar. They have to match up, right? Long sides not going to be similar to the short side of another triangle. That wouldn't make sense. Well, yeah, so they're just already matched up if I list them out that way. Great. 39.1 over 17 equals x over 25. Okay. I use cross products to solve now. And when I do cross products to solve here, what do I get for an answer? Read? 57.5. Now let's think about this. If we are going in order from least to greatest, I know it has to be at least greater than what?
48.3.
It has to be at least greater than 48.3, right? It has to be the longest side. So use that logic to help you answer these questions. Like, let's say you did make a mistake and you got an answer of like 32. Would that make sense to this problem?
No.
Okay, so think about those things as you work these out. Here's your assignment.